So apparently it works. That's good. 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 Nice to know that stuff is working. We are facing here some technical difficulties, but I hope we'll be over that soon. Any feedback will be welcomed. If you'll just write down that stuff is working, that will be awesome. Fantastic. That's great. So as I have said, it's to the guys who are still sticking to the WebEx meeting. Uh, Everything has moved to the YouTube live stream. We are having a lot of interest in this event, and apparently there was yes, we hit some limitations I was having. Therefore, I moved to the YouTube live. Fantastic. Yes, you can just close the WebEx. To all of you friends just joining through WebEx meeting, please use the provided link in chat to jump over to the YouTube live stream. It will be more convenient because then I will be focusing only on one chat and possible replies. Hello, everyone. I'm Mike. Welcome to my presentation on a VIweek about the G language and going beyond. Right now, we are still having a presentation of Tom McQuillan running. So I would like to wait maybe 1, 2 more minutes for making sure that he will finish his talk. And yeah, all the people who will be willing to join us will also be able to have a chance to to join and to hear all the introduction from the very beginning. Nice to hear, Kabul. Yeah, there is a plenty of stuff in the back to watch. My kids love to to crawl over the desk and then find all the crazy stuff on this drawing or on this picture, actually. Painting, that will be more correct. All for all you for all friends on WebEx, it will be fantastic if you could just join on the link provided in chat and switch over to the live stream on YouTube, where I was facing some technical difficulties, and if you could just jump over there, and we will continue the presentation on YouTube Live. So Tom finished. Fantastic. So that's really good. Yes, I think that having a bigger breaks between sessions was nice. So first of all, hello, I'm Mike, and I will just start my presentation. Give me a second here. Uh, yes. So I would like to welcome all of you who came to look a little bit on graphical programming beyond G, use case of LabVIEW integration with Node-RED. I'm Mike. I'm functioning under different names and different forums. I know that's my bad, but I'm trying out to work on branding that everybody will have a little less difficulties recognizing me later on. I'm writing a spaghetti since LabVIEW 2007, where I started. I inherited the VI, which looks exactly as one of those VIs everybody shows as spaghetti code. It was that one huge VI controlling several lasers. So also I'm involved and having a lot of fun and pride to work together with guys from G Central, from GDCON. I'm yes, I have organized the Discord channel for our first VIweek conference. Also, I'm actively participating in the LabVIEW Advanced User Group Denmark because I come from Denmark. Uh, when I have more time, I'm playing one of those. It's pretty nice and easy instrument and makes cosmic sounds. Uh, I loved it when I first time seen it. Our giants are female. Following the very nice example that Fabiola started on the GDevCon, I would like to present you Caroline Porco, who is planetary scientist. She was a member of a Voyager imaging team. She was a leader of Cassini imaging team. She is expert on Saturn, on its rings, especially on its moon, and she is the role, I would say, role woman that each boy could imagine to be, just shooting to the stars, seeing it from the close distance. She is amazing educator. She has a few TED Talks, which are very entertaining, very visually nice, you can imagine, with all those photos out from space. And she was advisor on a Star Trek series. Definitely somebody to know about, and Mm, I'm proud to have a chance to talk with her 2 times. So we are call ourselves graphical programmers. There is a paradigm of graphical visual programming, which falls into generally into two categories. There is like no code, drag and drop programming, and data flow. So I will first focus on the no code and drag and drop solutions. And the most known example of that is Scratch. Scratch is an amazing tool that lets very young students, kids, to learn all the programming paradigms, loops, variables, changing colors, making animations, just learning by fun from the very early age. Um, it is provided by MIT, and they are still working on it. And their main audience was kids in here, but they have evolved this idea, and they created something like App Inventor, which is a full-blown programming language that you can start to program on Android devices. And it consists mainly of two different views where you can still using those puzzles and small other features create a program, but also you are having another view where you organize and plan the view on your mobile device. It was an academic idea, but there are spin-offs from that. So one of the most popular language just like that right now is called Thunkable. Uh, It has more features, it has more libraries, it has support for a lot of phones, a lot of crazy features of those phones. And me not knowing this at all before, it takes like 2 days to create application that over the Bluetooth connects with a serial connection, creating a Modbus or talking to a Modbus device, making a supervisory system that can read, write, and control from a mobile. 2 afternoons. It's really powerful stuff. Let's go to Dataflow. Dataflow naturally emerges in some systems like audio systems. They were using cables and connecting wires from input to output through different modules from very early on. Therefore, there is a very known and widely used in audio processing domain software called Reactor version 6 at the moment, where you're combining instruments, virtual instruments, one after another. You can uh, you can create complex networks where you connect inputs to outputs, change the parameters to create sound, music, performance. It's a very powerful and very widely used tool. Similarities to LabVIEW, yeah. Another place where Dataflow appears naturally is video and graphics processing. Very good example here is Blender. Blender is a device it's a software for rendering 3D objects, for modeling and rendering them, not only static but also animations. It uses its own language to mix colors, to mix surfaces, to quality types of surfaces and features that are on them. It also uses it to change the parameters of renderers, so to obtain very natural looking views. Once again, the concept is that we are having sinks, sources, instruments in between connecting by wires. Programming, you have most likely you have heard about Unreal Engine. Unreal Engine sits behind many games that we are maybe not anymore, but still some of us are still playing. It's a graphical programming language. It's called Unreal Engine Blueprints. This starts to not only to have just a data flow, it starts programming where data flow controls the lightning, controls the figures, controls all the elements of the world which is being created in games. So we are getting closer and closer to something we can call real programming language. But let's take a step back from from it, because natural flow also appears in statistics, where we are having a set of data and we need to process it. Usually by the whole batch which comes at the input needs to be filtered, pre-processed, analyzed, and that's the ideas which are used in SPSS modeler powered by Watson on IBM, where once again we are connecting sources with sinks, and there are several processing elements in between. Once again, we kind of start to recognize the same patterns in here. Those are very, very powerful tools for statistics, data mining. When we are in data mining, very naturally, we move to the next step, which is machine learning. Azure Machine Learning Studio is a fantastic visual aid to process lots of data and to use it for machine learning. I'm cheating in here a little bit, as yeah, machine learning is kind of statistics, but I really love this example of Azure ML Studio. It is very, very powerful. And once again, use the same concepts. The very interesting thing which is happening here is that normally you think on the flows from left to right, while in Azure ML Studio, from the very beginning, users are being taught to have it top down. Interesting finding. Yes, when we were talking about, or when I was talking about the machine learning, it's very closely related to IoT revolution. IoT revolution happened, is happening right now, um, and it is all about interconnecting devices all through the cloud, devices with services with all sorts of APIs, and that's what is Node-RED. Node-RED, it's a very important player in Internet of Things, in industry Internet of Things, and I would like with this presentation to show how we can integrate Node-RED with LabVIEW using example of LabVIEW Community Edition running on Raspberry Pi. So what is Node-RED? Node-RED is this is an open source solution, so it's free. It is developed by many people. You have issue trackers on that. You see what's happening. You can be part of this development if you want to. It is a tool to rapidly interconnect physical devices, cloud-based systems, databases, APIs, and the power of of the Node-RED is that you don't need to be a programmer to do that. You don't even need to be a person to do that, actually. It is very, very, very simple, and it's programming less programming, something that LabVIEW is also advertised as. But it has a little different concepts than LabVIEW has. It is a very rapidly growing tool. The community is getting bigger and bigger, and it gains support in more and more IoT and Internet of Things and industrial Internet of Things domains. How to get it? It is out of the box available on the Raspbian distribution. So if you would like to test your new LabVIEW Community Edition on the Raspberry Pi, Node-RED is already there. So that's very, very nice of them. And so it runs on the Raspberry Pi, and now I see I have really bad text there. I don't know why it happened like that. How to start it up on Raspberry Pi? Just type node-red start, and it's running. So Instant is immediately, or in a very short period of time, available on the address of Raspberry Pi port 1880. So let's go there and let's check how it looks like. Ooh, too far. So this is a Node-RED instance. Node-RED instance, it has a palette, as we are familiar with, of different inputs, which are several of them are core inputs, like inject core, which can start a flow, and a main sync, which is a debug. It has plenty of functions that we can use and we can play over with the flow, with including delay, including execution of the code on the machine we are having, um, including networking already built in, including some input and output, and what is very interesting, parsers for a lot of forms, a lot of types of data that we can reach from different APIs and different services. We have access to local and cloud storage. By default, we have a Twitter API. We easily can install Modbus libraries to talk over Modbus, not only TCP but also serial, with the usage of whatever serial to USB converter connected to your Raspberry Pi. Uh, and we have a native support for Raspberry Pi GPIO pins. So this is pretty powerful collection. So I want to introduce you to this language. Therefore, first thing what we need to do is to run our Hello World program. So here I started from having an inject node, which I called Hello VIweek. If I will double click on this one, it immediately pops up with a screen of configuration. In here, the only configuration is that payload that it creates should be hello VIweek. Also, if I will be starving for some more documentation is readily available upon pressing on a I button in here. It has pretty extensive documentation what this node does for such a simple node. So this node is connected to a debug node, which I called our first output. Our debug node, again, if I press an I button, has a pretty extensive documentation what it does and what it can do. It is configured to display a payload that it does and that it receives, and it displays that on a debug window. So here we are having a little buggy. That's our debug window. By pressing a small button, I can start a flow, and it makes that hello week send a message to first output, and first output place it on our debug screen. Hello VIweek, first success. We are already programmers in Node-RED. So that's how simple how it can go. However, I would like to show you what actually we do have right now. I will come back to my slides and show you that this is our setup right now. We are having a Raspberry Pi. On Raspberry Pi, there is a Node-RED instance. And in this Node-RED instance, we have a block that sends data to debug. As simple as that. Let's go back to our fun, because maybe some of you have noticed that there is a magic number appearing in here, number 11. It's because this message was not only sent to first output, but also down there where I hid it from you, just for sake of fun, to have another screen. In this screen, we are having two different sets. One very important set of the Node-RED is catch all. Catch all catches all errors which can happen on particular pane, and what it can do, it can send an error message to my debug window, so I will be able to see it. However, our message did not end up in catch all. It ended up in this little magic block called count. This is one of the most powerful blocks in Node-RED. It is a function block, which you can find in here, which upon double click opens its properties, and it is a JavaScript code. So just knowing some paradigms on how the message is being constructed, the message that reaches the system, this message is available for me in this block, and I can do and act upon this message. So what I do here, I'm each time the messages are arriving, because each block is executed only when message arrives. I'm from the context, I'm getting a variable count. Context acts as a feedback node. So feedback node which lives only in this simple block. So I can read out what is the value, what was the last value of the count, increment it, set it back to my system, and create a new message where payload of the new message is the count. That is return the message at the end. That's why you have seen 11 here, because it's a count. I will just scroll up, press again, it shows 12, press again, it shows 13. It counts up our messages. Um, so this is very basic approach, and here we could already do some fun, but it is very limited fun. I promise to tell you that this Node-RED can integrate different systems from different services and APIs. Also tell you that I was playing with a Discord channel for this event. It's the first time I was playing with Discord, so I decided that I need to use that. Oh, and my Discord has actually an error, because here I installed a collection of values, or collection of blocks, which is dealing with Discord, because in Node-RED it is very simple to install uh, blocks that will connect with the particular service. All you need to do is to go to Menu, Manage Palette, and in Install you can search for whatever module you want. You can find Modbus modules, Modbus modules. You can find Discord modules. That's where I found mine. If you would like to parse, let's say, posts on LinkedIn, you should. There was a LinkedIn engine. Maybe I made it up. However, the collection in here is about over 2,500 different modules that you can use, and they are pre-programmed to connect to a variety of services. And if this little fellow here claims that there is an error, I'm really yeah, okay, it was not such a big problem, because actually we could see that what I tried to do here was to set a function process message, where process message would once again count amount of messages, would set another message with the length of message received, and with the content of the message. That's what we see in the debug window. Since I started this instance, there were 387 messages appeared on Discord. Last message had 114 characters, was 114 characters long. And here is a text. I don't know who wrote that, but it actually is a message from our Discord channel. So that's how I have already connected to the real world. Mm, but just being connected and looking on a boring on a boring screen of the debugger, it's no fun. You can see this big fun in here when there is a lot of different connectors. I would like to drag your attention to the count of message and graph, count of message and a small text. Those blocks are coming from a dashboard collection, which is an integral part of Node-RED. Dashboard is just yet another part of the system which is available upon start. Oh, yes, it will actually start, please. So here we can see the graphs. Here we can see the values we have put in there. So Discord messages is the last message we received as a testing my Node-RED server. The last message was 28 characters long, and there was nearly 400 messages. That's how it looked like from yesterday. There was a big discussion happening in here. Overnight there was nothing, and today we started to talk again. So I'm a little bit worried by no, the messages are flowing. You can see that if I will ask you to write something in the on a Discord right now, most likely it will just appear in a iBlick to be in here. Um, as we speak about that, I would like to drag you back to my presentation because here I will tell you where we are now. We have connected, I have connected, you can do it the same, it's very easy, Discord over internet, talks to Node-RED installed on Raspberry Pi. Actually, that's not true. It's this small element which pulls the data, and I have displayed it not only on debug but also on a dashboard. We are already building up some system in here, don't we? So just let me go back here. But also there is more messages than more connections that we only see. This is an out of pane connector. When I click on it, it will tell me that this message will flow further, flow further to the different tab. If I will click on it, we are going to MQTT tab. In the MQTT tab, and you can notice that here it is highlighted exactly the one I have marked in the previous tab. I'm sending this data to count of messages channel because this node is a node sending data to MQTT to topic called count of messages. For those who are not familiar with MQTT, MQTT is second. For those unfamiliar with MQTT, it is a lightweight, secure, low overhead publish subscribe system, and it allows for low coupling between the elements. So it works in a way that it avoids a direct connection between devices. Each device needs to send data to central server, and then the server will send out the data to all other devices that have subscribed to this particular channel. It lowers the coupling on the system. Yes, it introduces delays. However, it is very versatile, very broadly used, and I'm pretty sure it's also a part of Raspbian distribution, and it is one of the mostly used IoT protocol due to its simplicity. Even Fab was writing in one of the chapters of her new book about that. So that's where we are here at the moment. we are having Discord over internet, writing to not only to Flow and to debug, but also to MQTT, and MQTT relays back the same information through Node to the dashboard. I haven't shown you this part yet. I'm just going there. So here is the part which is responsible for sending messages. Here we are having a part which is responsible for getting the messages back. Those messages received back are visible in another tab on a VIweek MQTT dashboard. So here we are having the messages received from MQTT server already. And here I have added another metrics, which is message length, but on a chart. So we can see that every now and then there is a spike. Somebody puts all the really long text out there. Yes, that still is, it is interesting, but it doesn't include too much interaction with LabVIEW, and I promised you to that we will do something like that. So let's go to my LabVIEW project. So I made a very simple setup where I'm having a Raspberry Pi, which is not connected at the moment. And there I'm having a main VI. On the main VI, I'm having an instance here of example. And sorry, yes, yesterday we have heard how it's bad to use just examples and drop it in our systems. But this is example of MQTT reader subscriber, and yes, and we are up there and running. So this is a VA running, and already you can see here the last messages which were being sent to us. So last message was Rabul. We can I ask somebody to send information, send something on the Discord? We should already see it in here. Nope, we have an error. I will try to restart. Yeah, now it looks a little better because I have a proper screen of deployment. Yes, and yes, now we can see that somebody claims how my face is nice because I will just do I have I created it? Yes, I'll just increase a little bit the size of the messages. Please go crazy and start to write something on a Discord. Those messages will start to appear. Exactly, frozen video. Whoa, thank you. I will try to do something about that. It works on my end, so maybe this is a network buffering. Be patient. Be patient. You'll see it coming. So we can see that it actually does work. It's not really, I'm not really lying to you. So we are having a live connection here. Let's see what we have done here. So, oh, sorry, that was too far. Uh, Sorry guys, I'm having missing slides here. Oh, I'll just click through that. We should be one earlier. Sorry, something went really bad right now. But yes, that will this is the total view we are aiming towards. We are not there yet, but we are having a Discord channel talking to one of our flows, which talks over MQTT, and MQTT talks to LabVIEW. That's the part we see right now. Unfortunately, you already got the spoiler of my presentation because I wanted to go there nicely step by step. However, if we'll move back to our Node-RED, we can say that it's not the only way of communicating with with Raspberry. We can also communicate with it over REST API. And in LabVIEW, once again here, in LabVIEW you can see that I have created a RESTful API with the web resources with the set string out and set string in values that actually that allow to send me some text. If now I will wait, we are here MQTT because I lost my slide for some reason. I will recover by doing so. There is a fantastic tool for MQTT which is called MQTT Spy. MQTT Spy is a tool that allows you to connect to different channels, to different topics, and displays it live. So I would say we are interested in here in two topics, REST out and REST out 2. That's how the output names from those two VIs are being called. If so. Going back to our Node-RED scene. Yes, I can going just tiny second, please. Yes. So here once again I have a trigger method or input inject method, which does nothing else, just creates a message. Then I have a block out of networking nodes. Networking nodes allows me to create a get a get method on the URL where my API is living. This API is living on REST on LabVIEW, and we will try to read the string out. So if we will try to read the string out, I'll trigger it. It successfully passed the system. No, it did not successfully pass. I have error 404. This is a very interesting message. This message comes from my catch-all. You can see if I hover over it, it gets a little red dots. I need to fix something. As usually as Fab was saying, if you do presentation, record it in advance. I'm pretty sure something went wrong with my server for REST, and yes, now I hope I have fixed that. So let's go back to Node-RED. If I will trigger, yes, it's successfully injected trigger, and this is the old error. What we should see in our MQTT spy, there should be a message on the REST out, hello world, and hello VIweek. These are uh, these are two messages which I have which those web VIs or these web resource VIs are sending. However, having only one-way communication is not fun. Therefore, I have created also another call which can once again have a get message, but this time it does set the string value to hello to all. It will change an internal state of our REST API to do so. So I will just call it and try to redo exactly the same call again, reading the outputs. If I will read the outputs once again in MQTT spy, you see on out addressed out is hello all, but rest out. Oh, now I'm puzzled. That should have been different. Mm, Okay, so my presentation did not work perfectly well. I hope you can see here a nice number 5 as I have 5 messages already passed. Each time right now I'm pressing the button to trigger web or REST API flow on my Node-RED. This number is increasing. So that's the only sorry, that's the only way I can show you that actually LabVIEW processes this information and sends information back because we can read it out. How we can do that? How we can read out the message from LabVIEW? So let's go back to Node-RED. After setting a call to LabVIEW, I'm getting result which contains 2 values. And then I'm using one of the JSON files to parse the response from standard reply from LabVIEW in a JSON format. And once again, I'm pushing it to a different tab. Different tab lives on MQTT tab. MQTT tab sends it to another output. So that was a second way of communicating, but it's still not enough for me. And I would like to show you yet another way of communication. This communication will be via Modbus. I have promised that I have promised you that where are my slides here? That there is also we have already covered connection through MQTT for REST API, but right now Modbus goes to the view because on my small LabVIEW project there is a standard Modbus client. It's Modbus TCP client that I'm connecting to it, and I'm constantly reading out what it outputs. If we will follow the flow back again on the Node-RED, we will clearly see that if I trigger the value, once again I'm using the same trick of counting this amount. I'm setting it with the preset single register to address 1. At the same time, each 5 seconds, I'm reading holding registers of address 1, and I'm sending it out from this pane. Where? To MQTT, because it's actually very nice, because all information is going for a server, then I can look for all information on the server. My MQTT spy currently can say about, whoops, my Modbus. I hope it's visible in any way. Can I make it a little bit bigger to let you see that better? Yes. So currently the value read from Modbus is constant 0. To allow you to have a fantastic experience, I will just behind the scenes go to this tab and start to trigger the value. And I guess that in each second, yes, the value is changing. Each time I'm pressing the button to send the information or send the value one bigger than previously to the Modbus. our Node-RED is reading this from the Modbus client living on the Raspberry Pi, running in the LabVIEW LabVIEW environment, and sends it back to our MQTT. So I need to believe. I need that. I need to trust you're taking it from granted that I'm not cheating here too much. And so I was just pressing here a button, and uh, incremental value was sent to Modbus write. It was being read each 5 seconds, coming back to this tab. It was sent to MQTT system. Now I can show you nearly whole solution, because we are missing only one element to the all of it, because we have also covered right now all three: REST API, Modbus, and MQTT. Now there is this interesting part on top. I would say where I have my another view. Here is a set of my toys. So here I'm having a couple of interesting microcontrollers and chips and so on. I'm a maker. I like to have fun. This interesting guy in here, it's an electron from particle.io. This is STM32 powered microcontroller, which has its own GSM radio right now connected to the internet, to the particle.io cloud, which allows me to connect wirelessly to the systems. Right now I was charging the fellow to make sure it will not die. And I hope that you can see now that it is not really connected. That's the antenna. Can you trust me now? Yes. So it is not connected anywhere besides internet, and I have a button in here. This magic button, when I will press it, it will send 1. When I will release it, it will send 0. Where it will be sent? Let's go back to our slide. So here we are having my particle electron, and over 3G network, it sends this information to the base tower, and then through internet it goes to particle.io device cloud system, which is all-in-one service for having devices like that with over-the-air updates, with telemetry, with support with web ID, and a lot of fun. But one of them is possibility to relay the message to the internet, and through the internet it goes down here to our MQTT server. Now I will try to go and see where it is in here. I need to resubscribe. And let's go to our MQTT SPI. Now you can see that particle button is 0. How to make it so you will believe me? Just a small, tiny second. Give me small moment. Yes, that should be it. There should be a small delay. So I'm pressing this button, and yes, we already see 1. I release a button, and we will soon see 0, I hope. I really hope. Go to 0. Yes. Of course, this is a pretty long loop time, and it takes some time to go there and back. I think this is very interesting to see how quickly right now we can connect LabVIEW to the whole Internet of Things. It is a very powerful device, a very powerful system, which was given to the hands of developers, that with few clicks, now you can have a device that is extremely powerful. Now let me go to the chat because I may have neglected it a little bit. Yes. Node results amazing. Yes, it is amazing. Yes, it is awful. Oh, that was even your message, which was facilitated in one of the debug debug windows. What is the library I use with MQTT? The first one, actually, I'm writing my own MQTT library, but unfortunately, it's appropriate solution for my employer, which is pretty much more powerful. This is the first one I have grabbed in, and it does the trick. It's this. I'm getting some. I got lost. Sorry, guys. Uh, I will just quickly check and tell you what this library is. I hope that this is a good citizen. This is DAC.io LCC Peter Adelhardt. I can just show you off what library is that. Give me small, tiny piece of second. String in. No, that's not easy. It takes me a little bit too much time to find it, and I would like to. I will just share my desktop instead. Nope, it refuses to work as well. So, but yes, this is DAC.io. I can provide you the link to that in a chat. Let's go further. Node appears to use asynchronous data flow like LabVIEW channel wires. That's correct, or they have some looping construct that I'm missing. No, this is only a swim lane construct. You can create all the loops in a JavaScript code. Yes, so that's the short answer. Yes, but Fabiola books talks nicely about MQTT and LabVIEW with AVS. Of course, you can use AVS, but why? Today you can use our Raspberry Pi, and it's a sufficient and very nice solution to it. No law for ESP32. Not too familiar with that. If that's if this is what I think it is. Okay, those guys. No, I'm not too big fan. I never had a chance to play too long with them. Had a one which was buggy. I had problems. I moved to different ones. As you could see in my screen, I'm having. Oh, I see. I have one extra screen which covers me now. Yes. So. Good. So what we ended now ASP32. No, I'm not using ASP32 because I'm having fun with a different devices. Connection. These are the Electron device. I'm also in love with Arduino Nano. They are fantastic devices to use in any small project. Enough I/Os, enough digital communication channels. DigiSpark. It's a very tiny one. It's extremely interesting because it runs on ATtiny 85. It has a software USB, so it requires special drivers, but any small space constrained project, you can do tons of fun of it. And right now, of course, talk with Raspberry Pi over one of the digital lines. Um, from Particle IO family, here I have another Electron, which is GSM device, but I'm also looping it to the Argon device, which is running on Wi-Fi. Of course, Raspberry Pi with self-made case, and this fellow is very interesting. This fellow is I was just playing with the name and I'm forgetting about it. This is a Rock Pi. This is equivalent to Raspberry Pi in a small form factor. So you can see how much smaller it is. It is a tiny, has less GPIOs, but this device costs I think 10 or 12 bucks and can run full-blown Linux and have Ethernet connector. And this is what I needed it for. I needed it for a project where space is constrained. I want to write my library. I wanted to write my libraries in Python, but right now I'll consider running LabVIEW Community Edition on this toy. And stay tuned. I will definitely tell you how it went and what were the results. Henrik, node-RED trigger nodes can execute each X seconds. For loop, yes, they can be configured to be triggered on a time. They can be configured to be triggered on another event. So that's why I'm called they are in swim lanes methodology. So here we don't have a full programming interface. However, those swim lanes can be triggered. So I hope I have answered all the questions in here. Of course, shovel in more if you have. I will just jump to see other channels if there are other questions. Video lagging for anyone else? Sorry for lags on video. This is this is awesome. Yes, indeed, it is awesome. Question: is it just sub-VI nodes? Why scary? Uh, I don't remember when I have put that. I will come back to you with that question. I thought MRE could be removed from actual FPGA release. That was I guess some discussion happening in between. So I see that chat here is clear. In such case. I would like to thank you very much for participating in my presentation. I hope it was showing out that we are not the only ones doing wires. There are different approaches to that, and that actually release of LabVIEW Community Edition together with Link's toolkit, which enables us to use such as low-cost devices. It's not only those devices we can now speak with LabVIEW. It empowered us, the developers, not only us developers, but also all the newcomers who will just join the LabVIEW journey because of LabVIEW Community Edition. They have it at their hands. So I'm pretty sure it will empower the community to make tons of crazy projects. We just need to stay tuned and look at those crazy videos with crazy ideas of what people will do with those funny toys. So coming back to the chat, it is clear in here as well. Can you build an executable? No, it runs as a service. So this is a JavaScript back-ended.